All right, we're going now. Yeah, so I'll actually be able to show you something here. This is our project, right? Okay, so I'm going to grab that Git repository because I'm on a new machine here. So let's say you just went to a computer and you need to check out the repository. So most of you, when you go to do this, you hit fork first, right? That makes a copy of my repository in your account so you own it and can contribute to it and make changes and not affect my changes. If you check mine out directly, it doesn't fly. You don't have permission to write back to my repository. I would have to add you as a collaborator in order for that to work. All right, so I'll go ahead and copy this guy. We'll go into Android Studio here. I'll say checkout project from version control. We will, here, import project. Does this let me do it from there? Nope. Oh, from Git.
Yeah. Yep.
So I'll go ahead and paste that in there. That's where I'm checking it out from. I'll go ahead and hit test because it's probably going to make me, so I got to choose login to GitHub. What is my login? Nailed it. All right, so this should now work, I think. Oh, interesting. Let me. Well, I was over. Why don't I have my own Wi-Fi? I had a meeting this morning and they didn't have good Wi-Fi there. Top secret Wi-Fi. All right, so I'll go ahead and hit clone, and that should bring the project in. Accept. I have to accept this license here. Hit enter to view the license agreement. Agree. All right, so what do I have to just reopen this? I'm guessing Gradle
I
is.
think you already have it. You just have to click on the CSC. folder.
I don't think so. Let me just close Android Studio and reopen it because I think that's probably the thing it's complaining about. I don't want those tips. Well, And that's weird that it's, so let's delete that real quick and I'll just recheck it out. Where's my home folder? Shouldn't this thing show my whole home folder? All right, so we'll just delete that guy. We'll recheck it out. Yes, open it. All right, so now Gradle's running. I'm thinking that we short-circuited it last time, and with all my clicking the test button and stuff like that, it ran into some issues. All right, so let's, while that's cooking back there, let's see where we left off. All right, so before break, we were talking about communication between activities, and we had multiple activities working, and then we had a list of employee objects, right? So our homework assignment was, the previous homework assignment was to have a array list of employees that were created from our add employee screen. And then when we went to our list screen, it created a string-based version of that, right? So we had a array list of strings because that's what our default list view is capable of showing. Our default ArrayAdapter is capable of showing, right? So if we remember, I'll just put a new slide in here. So we have, I don't want to do that now. Couldn't connect to iCloud. That's good. It's gonna make me update Keynote before it'll let it work. All right, so while that's kicking, so our default ArrayAdapter does what? It adapts an array list or some sort of collection, right? Could be an array, could be an array list, could be a linked list, some sort of collection of strings. It adapts that for a default row in a list view. And also it'll work in recycle containers, which is kind of the more modern way of doing it, but we've only done it with the list view version of this guy. Now, what did that mean for us? It meant that when we went and created our array list of employees, we then had to, in order to display all the names of our employees, we had to turn that into a list of strings to work with the default. Now, can we imagine a world where having a list of employees would be beneficial? actually being able to show data about an employee in some sort of custom row in our list view. That would be more flexible, right? Because we aren't always going to be able to capture everything in a single string, or at least that might be more difficult than we want it to be. Something like that. Let's keep all these things updating. All right, so what I'm going to do is I'm going to go ahead and open up ArrayAdapter, Android on here. We're going to look at what an ArrayAdapter is, because in order to accomplish this, we're going to have to create our own custom version of an ArrayAdapter. And what this ultimately is going to mean for that might seem more daunting than it actually is, because there's only a couple of aspects of ArrayAdapter that we actually care about. Okay, so let's come down here, and we've already had our constructors for our ArrayAdapter. We'll come back to that here in a few minutes, but the one that we care most about here is this idea of probably this one right here. So we take in a context, because pretty much anything we do requires a context in Android Studio. We have to say, this is the perspective from which we're doing this. All right. And then a int resource. What is this usually? When we have a int resource or resource ID, what's that referring to? That's probably something in like r.id. something or other, or r.layout something. So a unique identifier for, in this case, probably what our row is, right? So before, what did we say? We said Android.r. What was like a simple list item row or something like that. Well, now we're going to want to design our own rows. All right, and this last guy is going to be our collection of objects. So when you see something like T here, that's a type. So a type of collection. All right, so notice that we have a constructor that looks like this that'll take an array. We have another constructor that's effectively the same constructor, but this guy takes something that's a list type. All right, if I click on list here, I think we did this last class, we see that we have all sorts of things that come from list. It's a little bit bigger here. So we have an array list is one of those things. A linked list is another one of those things. Stacks are another one of those things. So when I say a list, I'm saying a collection of stuff. Anything that is a list gives us an arbitrary size collection. We don't know how many things will go in there. Where anything that's an array will have a fixed size. Make sense? One's not better or worse than the other one. They just are solving a slightly different problem. All right, so those are our constructors, so that's kind of what our target's going to be, but we only care about a couple of things here. When we think about how we use our ArrayAdapter, we tell a list view about the ArrayAdapter we wanted to use. And somewhere behind the scenes, that list view is magically using that ArrayAdapter to fill its rows with the data that's in this collection. So somehow an ArrayAdapter is going to take each object that's in this collection, and it's going to create an instance of this row. And it's going to take the pieces of that and put it into that instance of the row. The default version of that, this row is just a text view. That's all it is a text view. Whereas, and that text view can hold a string. So we set the text for the text view. That's what the default version of ArrayAdapter does. That's what we used before. Now, if we want our employees to look better, maybe we have a couple of rows of things, something like that, we're going to want to pass it a different resource and a different collection. But the problem is, if I pass it a different resource here, and we come down to this method, get view. This guy right here. So this guy takes in the position, so the bucket number in our array, in our collection. He takes in what's called the convert view. So the convert view, this is our row. So this was automatically generated from our ID. So Android.r. simple row item, whatever. So one of those was created for us, and that gets passed into this get view automatically. So we're talking about the default get view. We haven't written our own array adapter yet. We're using the default array adapter that I promise you this convert view will be just a text view. All right? And the position is going to be reading in from a collection of strings. And what is he going to do? He's going to set the view for this guy or set the text for this text view to be the string that is at that position in our collection. That's what the default one does. If we want our collection to have employee objects in it, do we think it's pretty likely that the people who wrote the ArrayAdapter class didn't know what our employee objects look like? They didn't know that we had these 2, 3, 12 fields in it. They didn't know what our convert view is going to look like, right? They didn't necessarily know we were going to have these different text views and things like that, or what we imagine our rows to look like. We weren't going to have those things. All right, so what we need to do here is we're going to have to create our own instance of ArrayAdapter and write our own version of getView that knows how to, from this guy, get the elements that we need to work with and fill them in with the employee that lives at that position in our collection in whatever way is meaningful to us. We have to teach our specialized version of ArrayAdapter to do that stuff because we're moving beyond the default ArrayAdapter. That make sense? If we keep going down through here, let's see, anything else we want to override? Get count might be something we will override as well. We don't necessarily have to. It all depends on how we store our collection. If we look up here at fields, here's our constructors, here's our methods, where's my fields? Okay, we don't know what our field is called. That's fine. So we will have to write get count from here as well. All right, so let's just dive in and look at how this is going to work. We are going to have to create our own thing that is a ArrayAdapter. So what we're going to do here is we are going to work with inheritance. Oh, I need to reopen Keynote. Yes, yes, yes. All right. So we have something called inheritance. And what is inheritance? Inheritance, if you remember when we create classes, we would say like public, class, employee, and that's where we end that thing, right? But there's a little hidden text there. So if I do like, there's something going to be here that says extends object. All right, there's this invisible thing that is at the end of all of our classes. If I go in here to our code, I go to Java, here's our employee class. And can I make it bigger right here? Preferences, editor, font. Is that big enough? You want bigger?
No, it's pretty good.
That's good? All right. All right, so here's our employee, our constructor for employee that takes all of the stuff in his parameters. Here's our class employee. Up here, there is something extends object that I promise you is there. That our employee is something that is a object in Java. Okay, I think we've drawn this before, but I'm going to go ahead and give ourselves another hierarchy picture. And we'll do this for ArrayAdapter, just so we specifically have our example here. So we have this top level thing called an object, and this is not just the Java concept. This is a concept that is for any object-oriented language. There is a top level thing called object or similar, something like that. That is the core that all other objects are built in terms of. Okay? Now if I go back here to my ArrayAdapter, we see that ArrayAdapter is actually something that comes from base adapter. And a base adapter is something that comes from object. Okay? So all right, so these are the classes that already exist. We've been using an ArrayAdapter, which we didn't write. And we can put a little thing next to this that says adapts array of strings to a text view. Let's just say that's what that dude does, because effectively that's what it does. All right, everybody's cool with that? All right. Now, an ArrayAdapter actually is something called a base adapter. We don't know what that is. We go into the documentation. We see this thing called base adapter. And then we notice that this class is something called abstract. All right. Now, a lot of these things we're going to be talking about here this last week of class are in preparation for 300. All right, so we're not going to go too deep into these. I won't test you over these. We'll talk about the final exam on Thursday. But I'm going to introduce the concept of abstract to you right now. So I'll just put it in here as this guy is a abstract class. Go ahead.
Then you would recommend that not only do we remember all the stuff that we learned in this class, but we also we should remember this basic stuff for if we were taking 300, like this next part.
Well, I'll review it again.
Yeah, just go over it again, just have that in your head.
Yeah, I'm giving you a little bit of foreshadowing of what we're going to be dealing with. So, right now, what has this class mostly been about? It's been about learning Java syntax in the context of Python, right? So you notice that things that we did in Python, we've done again here in Java. We've taken our objects a little bit farther. We've practiced with them more. Now we've looked at it in the context of Android Studio, so now we can build more interesting interfaces and things like that. But really what we've done is we've given ourselves another semester of practicing with the core programming fundamentals, and then stacked on top of that maybe 25% new stuff. Okay, so now going into the third class, what we have is let's call it a fairly intermediate programming background. So we have solved harder problems in here than we did last semester. So now when we go into that third class, now we're going to say, all right, well, we're pretty good at kind of using those generalistic programming tools for solving problems, but what if I need to invent my own tools to help me solve even more complex problems? So right here, we're about to invent our own tool. We want to invent our own very special ArrayAdapter. All right, so this is going to be kind of the start of that. We're going to spend most of next semester inventing our own tools to then turn back around and use those tools, use those data structures to solve even more complex problems. So we're going to start off next semester still in Java, still using Android Studio, and we're going to transition to C++ in there. which will then give us a lot more practice with memory and pointers and things like that that are going to allow us to solve even more complex problems. All right, so even if you are an IT major, I'd still encourage you to take that 300 class. It's not required for IT, but it does count as one of your electives. Promise you the knowledge in there will benefit you in your IT career. All right, so if you're not enrolled in 300, I would strongly encourage you to do so, even if you've decided you haven't fallen in love with programming. Because I get it. You know, typically in a class, let's say you have 10 students in a class of in a programming class. You're probably going to have, let's say, 3 that programming is their thing. They just like it. They know that's what they want to do with their career. Then you're going to have another 3 or 4 that are like, you know what? I can tolerate this. I like it sometimes. Maybe I want it to be part of what I do as my daily thing, but I don't think I just want to sit at a desk writing code all day. All right? Now, I'm telling you that an IT person is going to fall into that category whether you like it or not. There is going to be programming type concepts that you're going to have to deal with, even if it means writing shell scripts. Maybe it's in C++, maybe it's in Bash Shell, maybe it's in Perl, some programming language. And one of the things I really drive home is this idea that programming is the skill set. The language doesn't matter, right? So you're going to be having to write programming stuff as an IT person. In fact, a lot of times I make the argument that the programming you do as an IT professional is actually more complex than the programming you might do as a computer science software developer or something like that. Because since computer science folks spend all day, every day, let's say, writing software or something along those lines, we typically have nice advanced tools that allow us to do this nicely. Drag and drop a button in there, hit a little drop down and say, when this clicks, do this. We have, these nice tools for building our stuff. Where a lot of times for an IT professional, you are writing some code that's going to run on a managed router that sits in the basement somewhere across, in our case here, somewhere across campus, that you're not going to go and sit in front of this machine with a little keyboard and mouse. Right? You're remoted into it from a terminal that looks like this, writing code from the command line, using some command line text editor like VI or Emacs or something like that, not necessarily working with the most friendly environment. That makes sense? So sometimes your life actually is going to feel a little bit more complex to do those things. So having those programming skills, having that extra semester of practice will really benefit you. And I actually would make the argument that it'll improve your trajectory in your career because it makes you the person who has a little bit more of those, let's call it cross-training type skills in your IT career than maybe the person sitting next to you at work. So I'd encourage everybody to take the 300 class even if you're not in love with programming. All right, so most of those 3 or 4 people in the middle, that's probably your IT group. If you're an IT major and you're in that top 3 group where you just love programming, you might want to think about switching majors. Switch over to computer science because it's going to, I would argue, maybe look better on a resume, certainly better on a resume for that type of job. But at the very least, it's going to put you on the trajectory for that type of career. Where IT is going to require you to take some other courses and also put you on a different trajectory for a career. Now, if you're in that bottom 3 or 4 people where you've just decided programming is something I never want to touch again, I'd encourage you not to take the 300 class, but I'd also encourage you to really ask yourself the question whether this is the right field. Because I promise you IT does not mean not programming. It is the wrong way of viewing IT. Like I said, in IT, you will do programming, and in some cases, it'll be significantly less friendly than the programming you'll do in a computer science development career because you're not going to have the evolved tools to make life easy for you. All right? So, in any case, we have this array adapter that was provided for us, and we know what that guy does. We have this base adapter that was created for us that, for whatever reason, an array adapter was built in terms of that guy. But this guy was built as an abstract class. Now, what does it mean for a class to be an abstract class? This is a class that exists solely for the purpose of inheritance. Abstract classes cannot be instantiated. So in our example here, we have this thing called a base adapter. This is illegal code. I cannot create an instance. In this case, BA is a variable that holds an instance of base adapter. This is illegal code because since base adapter is an abstract class, I am not allowed to create instances of base adapters. Base adapter exists solely to support the inheritance model, where an array adapter is a base adapter. It's one of those guys. He's built in terms of a base adapter. Okay? All of us are humans, right? We're all human beings. Now, if you walk around the halls of campus, can you find a completely generic human out there? Or you're always going to find males and females and even further specialties, right? Okay? You're not going to find the generic human. So in our real life example, human would be an abstract class. We cannot create a generic human. But all of us in here, males and females, we have commonalities, right? That belongs to all humans. So that human class exists to give us those core functionalities of all humans, right? And then we have males and females that we do have instances of males and instances of females that get everything that humans bring to the table and then have the differentiating factors that make them male or female and so on and so forth. All right, we won't draw any pictures. All right, go ahead.
So we couldn't say ArrayAdapter was an instance of base adapter because it's too specialized.
Well, it is. So she's asking the question, first of all, can I do this? Now, I'm pretending like there's a no argument constructor. I think there actually is one. First of all, this is legal because ArrayAdapter is not an abstract class. So we are allowed to create ArrayAdapters. Now, we would ask a question. Is A an instance of ArrayAdapter? Yes, it's one of those, right? It is an ArrayAdapter. Is it true that A is a base adapter? Yes, it is a base adapter. Therefore, it is effectively an instance of a base adapter and then some extra stuff. Make sense? But I could not directly create a base adapter. So from ArrayAdapter's perspective, super is the parent instance, which is a base adapter. So this, we've talked about super, haven't we?
Yeah.
Okay, we mentioned it. Now it's going to become much bigger now that we're doing inheritance. I'll just throw another slide up here real quick just as a reminder. So super versus this. This is how an object refers to itself from within itself. Super is how an object refers to the instance of its parent from within itself. So from ArrayAdapter's perspective, example, ArrayAdapter. This is the instance of ArrayAdapter. super is the instance of base adapter. That make sense? You don't have to use the super keyword. You may never want to refer to your parent. You might want to just say, look, I have my own special stuff. Okay, and anything that I need, I have enclosed in me, and maybe it was implemented in terms of the generic base adapter, right? So whether we're males or females, we all have hands and they work the same way, right? Okay, so we're taking advantage of that aspect that we inherited from our humanity. All right, but we don't need to go ahead and ask our human-esque subsystem to say, well, I want to use my hand now to pick up my coffee mug, so I'm going to need you to do some heavy lifting for me, right? We don't think about it like that. We just have that ability because we got it from our parent. Does that make sense? But every now and then, we might have our own version of something, and then we have a parent that might have their own version of something. So for instance, we've looked at the toString method historically, right? Because every single object comes from object. And as an example for us, one of the things objects give us is a method called toString. Remember that guy?
Oh, yeah.
All right. And what does toString guarantee? This guy returns a string representation of this object. Here, this is going to make life easier. Usually a memory address looking thingy. Okay, we've seen that before. All right, now if we want our objects to give us something that looks less memory addressy, we can write our own version of toString, which would be a more local copy of it that can make our object, our ArrayAdapter, our employee, whatever objects we're inventing, look like something different than a memory addressy thing. But we are guaranteed to always have a toString method, whether we write one or not, because it came from somewhere in our lineage, even if it's from the very, very, very top, which is object. Make sense? Go ahead.
All right, so to clarify, object would be the parent?
Well, in this case, ArrayAdapter's parent would be base adapter. Base adapter's parent would be object.
Okay.
So we would call ArrayAdapter's grandparent the object, but we don't have a keyword for that.
And then the adapter is an abstract class because it only
This guy is an abstract class.
Yeah.
He only exists.
The base adapter is an abstract class because he only exists. So both his parent isn't an abstract, but he is because it's only used for reference to the array list.
Correct. Objects are not abstract. Actually, I don't believe objects are abstract. I'm pretty sure they're not. If I was building the language, I would not make them abstract. Yeah. So objects are not abstract because you always need to be able to create one when you use the new keyword. Object is like the special kind of animal, right? It comes with the language, everything is built on top of it, so it has to like exist in a very specific way so that that whole equals new thing works, because you will always, even when we created our employee class, which extends object, even though we didn't say that, I promise you it does, it's gonna have to create that variable called super, which is an instance of object. It's gonna have to be able to create that guy.
Right, so something can be built on something that's not abstract and still be abstract.
Can something be built? Well, yeah, I mean, like our employee is not abstract, and it's built on top of object, which is not abstract. All abstract says is we can't have one of those in reality. It's a stepping stone to something more specific.
Oh no, what I was basically saying is that so if you have something abstract, it doesn't have to be built on something abstract.
Correct. Yeah, oh yeah, that's 100% true. Yeah, if something is abstract, that does not dictate who it came from. It could be abstract, it could be non-abstract, that has no bearing on it. Yeah, they all having something abstract says is we can't naturally bring base adapters into the world. If we want to have something that is a base adapter, we create an array adapter or something even more specialized, which is what we're going to work on.
So you would have to change the code in order to make it non-abstract.
Correct. Well, you actually don't have to change the code. We could just have a class extend base adapter and then put nothing new inside the class. And technically we're following the rules. Because we're saying, look, I know that you existed, the base adapter existed because you forced me to do something special, but I'll tell you what, I don't want to do anything special.
All right, so it's
So I'm just going to extend you so it'll work.
all right, so
This is probably a forced example, but it's legal.
it's technically possible, but it's not very useful.
Correct. Yeah, because you can also have abstract methods. So what you can do then is you can say that here's an abstract class, and now we have an abstract method, and that means you have to implement that method because you didn't get a copy of that method. It was mentioned as being defined. But at this point, it was mentioned as not necessarily being defined, but it is required. But at this point, we start dancing that line between whether we need an abstract class or we need an interface. Remember the interfaces that say this guy has to, you must implement these 3 methods in order to be, a whatever. We use the UPC scanner thing as our example. You have to have these 3 functions in order to do it. In our case here, we're creating our own array adapter. Array adapters already have some functionality. It's a real life thing. It's not just an idea. An interface would be an idea that says, look, if you want to play this game, you have to be able to do these 4 things. An array adapter is more than an idea. It's an actual thing, but you might say, look, I want to do a lot of what this thing already does, but I need to do a couple of its things a little bit more specialized. So I'm going to start with an array adapter, and then I'm going to override a couple of his methods with my own versions of those that do something a little bit more. That makes sense? Okay. And the thing is, keep in mind that object-oriented languages have a goal of allowing us to solve problems in a way that's similar to the way we already solve problems in real life. So don't try to make this too special, right? We already understand the idea of inheritance, right? Parents and grandparents and great-great-grandparents and so on and so forth. We have that model, okay? And when I say something like, if you walked out in the hall and I gave you a half hour to go find me a generic human, we wouldn't be able to do it. We don't have them just walking around. We have specialized versions of human that have a lot in common. Therefore, we've put the commonalities into this concept called human, but we say we can't actually create a generic human. The way to get a human is through either male or female. Make sense? That's how we accomplish that. All right. So in our example here, base adapter is like human, and array adapter would be kind of like male or kind of like female, something like that. We have to create array adapters in order to accomplish something. Now, what we're going to do is we're going to say, you know what? That normal array adapter isn't quite what I need. I need an employee adapter, or whatever you want to call it. So I need this guy, and I put him in green because we're making him. He didn't come prepackaged in Java. So now we're starting to invent our own thing. So we need something maybe called an employee adapter that is a array adapter, which is a base adapter, which is an object. That make sense?
So basically inherits all those properties.
Correct. Just like in real life,
Yeah, it's like
right? Some of us are walking around with our great-great-grandparents' nose.
Yeah, it's an
Right.
inheritance. And then in the same, not to for the sake of your analogy, because there's some things that we don't inherit. Would you say there are certain things with classes that you don't inherit as well?
Well, I mean, anything that's in your lineage, you are inheriting from.
Yeah.
So the human version of this, we have, various traits, various genes. Some of them are recessive, and we don't actually, they're not prominent.
Yes, that's what, yeah.
Yeah,
that's what-
in programming, we get everything.
Okay. So
Everything is accessible to us. We can choose not to use it, or we can choose to override it. If both of our parents have blue eyes, and I know that some of these things aren't even possible, but I'm just going to make it up. All right, so let's pretend this is possible. And I'm born with brown eyes. I'm guessing one of those is, I think, is blue eyes I think that's the dominant trait. So let's say brown is recessive, whatever. Let's pretend that's a fact. That's why I don't teach biology. All right, so let's just assume it's possible for both of my parents to have blue eyes, yet I'm born with brown eyes. So I overrode that default setting with a different color eye. And maybe that came from something that's higher up in my great-great-great-grandmother or something like that had brown eyes, and that was a recessive trait until it finally got to me, and coin flip, I got brown eyes, something like that. I don't. I have blue eyes, but, you get it. You get the punchline. All right, so this is modeled after the way real life works. So this is another example of how programming attempts to allow us to solve problems in the way that human beings solve problems in real life. Okay? So we're not allowed to create base adapters. We might say an object is kind of a waste of time to create, right? They don't do anything. They're just the building blocks for something. So we can't create base adapters because it just wouldn't make sense. Just like in real life, creating a human wouldn't make sense. We need to give more meaning to them. But if we're going to try to be efficient, we might as well kind of store the commonalities of humans in one place and then differentiate them through subclasses. Now, we can create array adapters. We've done that. But we happen to have recognized that the default behavior of an array adapter only lets us adapt collections of strings to a text field. That's what it does. And if that's all we need to do, then we're good to go. We don't need to create something special. Make sense? We can just roll with it. I want to show a string. You give me something that knows how to show a string. 3 lines of code. We got a list of stuff. All right. Now, if we want to do something more complex, because we've invented this object called employee, and employees have several pieces of information. Some are strings, some might not be strings, whatever it is, and we want to put them on the screen in a list in some sort of special format. Now we need to say, look, I'm going to create this new class called employee adapter, and I basically want him to be an array adapter, but I'm going to take a couple of pieces of him and make him something a little bit specialized. I need to teach him how to create, how to fill in a specialized row. That make sense? All right. So what we're going to do, we'll come into our code over here. I'll right click. I'm going to create a new Java class. All right. This is a normal plain Jane Java class that will happen to inherit from, we actually might be able to, it might be in here somewhere, ArrayAdapter, but yeah, let's just create a normal Java class. All right, and we're going to call this guy an employee adapter. We can name him whatever we want. We're just giving our class a reasonable name. It's still an adapter, but it's not a normal array adapter. It's an employee adapter. Okay, I could call this guy Elephant if I wanted to. That just wouldn't be very meaningful to us if we came back to the code 6 months from now, right? So he's an employee adapter. Now, we can choose to go ahead and look through here. Actually, not in this, you would say class, but you can choose to go ahead and put the superclass in here, but I'm not going to do that yet. I'm just going to leave it alone. I'm going to say employee adapter and go ahead and hit OK. It's asking me if I want to add this to my Git repository. I'm going to go ahead and say remember, don't ask again, and I'm going to say add. Typically, if we're going to create a new class, we want it to be part of our repository, right? So we'll say that. All right. Now, here's my employee adapter. Now, we want this guy to extend ArrayAdapter. All right, that's what we want this guy to do. So notice right now he's screaming at me. He's saying, there is not a default constructor. All right, so in ArrayAdapter, there isn't, so he's actually complaining about ArrayAdapter specifically. There isn't a default constructor inside of ArrayAdapter. Let me show you what that means. If I go back here to ArrayAdapter, that's base adapter. Here's my ArrayAdapter. Here's my list of constructors. Notice all of these constructors take stuff, right? We cannot build an ArrayAdapter with nothing, okay? If I were to try to create the syntax that is employee adapter E is equal to new employee adapter, like that. If I were to try to do that, and I don't specifically write a constructor, for instance, what I've done right now, if I go into my code, I have not written a constructor in here, right? This is an empty class that has nothing special about it other than, hey, I just wanted to rename this dude. Just cuz, all right? But since I haven't written a specific constructor, it will attempt to call my parent's constructor that takes no parameters. Just so happens that I don't have a parent constructor that takes no parameters. That's why it's screaming. So it's saying, look, if you want to be something that's like your parent but potentially more or potentially different, you're going to have to tell me how to build the parent. Okay, and right now you've said you want nothing, and I'm going to try to create the parent out of nothing, and that guy don't exist. Go ahead.
When we were creating the class, one of the options was superclass.
Yeah.
If we were to do that, would it just basically have done that?
Yeah, it would put the extents in there. Yep. But I almost always write it this way. All right, so we want to create our adapter, and let's just say we're using ArrayList right now, right? So really, this is the guy that we want. That guy that takes in a context, that takes in a resource, and takes in a list of objects, some kind of list of objects. All right, so we're going to come down here, and we're going to create a public employee adapter, okay, because constructors always match the name of the class, case sensitive and all. Constructors never have a return type in Java. They never have a return type in C#. They do have a return type in Objective-C. So these are things that might be slightly different in different languages. Why don't constructors have return types? This would be like a good final exam question. Go ahead.
They always return memory addresses.
Always return memory addresses. Why is that? When are constructors used? What always precedes a constructor? It's almost the same answer as they always return memory addresses. Who always gives me memory addresses?
Sorry, what?
Who always gives me memory addresses?
String?
New?
The new keyword.
Oh.
Yep. Constructors are always, 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 always preceded by the new keyword in Java and in C#. And since that's the case, they always boil down to a memory address, so this guy doesn't have a return type. A language like Swift, a little bit newer language, takes this one step further. If a constructor is always, 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 always preceded by the new keyword, and it always, 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 always returns a memory address, why does it make sense not to have a return type but still require you to have the new keyword there? So Swift says, hey, you don't even need the new keyword. Just tell me the constructor you want to call. I'll call it with a new keyword under the hood, and I'll give you a memory address. Because that's what always, 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 always happens. Make sense? All right, so Java only carried the ball to the 50-yard line. Swift takes it a little bit farther, and then the next language will say, look, we know you're going to construct something, we'll just figure it out. Based on how you use it, we'll figure out what you meant. You don't even need to tell me what kind of object it is. Then after that, it's like, don't even write the code. We got a neural network. We know what you mean. And then just watch the Terminator movie, and you'll see what happens. All right, so this guy's going to be an employee adapter, and then I'll go ahead and paste in those things because I want to build this guy in terms of my parent, correct? So for context, I'll just make sure I inherit android.content.context. On a Mac, that is Option Enter. If you just highlight over it, I think on a PC it's Alt Enter. I think Option is the Alt key. I'm going to call it 92.25% positive. So I think Alt Enter, if you highlight over a red thing, it'll go ahead and automatically inherit that. All right. Now, what we can say is if we are always going to build our employee adapters out of employees, well, we can come here to type and say that this is going to be a list of employees, right? And we can go ahead and inherit list. But at this point, we've never actually used list. We've used things that are lists, right? But from our world, we're going to always be building employee adapters out of array lists, which I can tell you is a type of list. We've seen it, right? We went and looked at ArrayList, and we kind of looked at his lineage, and we saw that his parent is actually something called a list. In fact, I'm going to show that to you real quick. So here's ArrayList. So I want to actually go to the Java documentation so it at least looks consistent. All right, so an array list is an abstract list. Notice that guy's an abstract class. An abstract list implements an interface called list. So in that case, we're actually talking about something that is compatible with things that are lists. But you can't actually create an abstract list. You can't actually, so if we look at abstract list here, and we see who subclasses this, we see that we have ArrayList, we have this thing called a vector. But if I look at list, this interface, this will show us all known implementing classes. Here's our all known implementing classes. These are classes that have said, yes, I will follow the rules of what it means to be a list. And what does it mean to be a list? A list says you must write these methods. You must have an add method. You must have another add method, all these things, right? You have to have a clear method. You have to implement all of these functions in order to be trusted as fulfilling the role of a list. You can write more stuff. You can have your Mike Littman's super secret list that has all this stuff in it plus 9 other functions that I invented. No problem, right? But at the very least, if you're going to claim that you're a list, you're going to say, I'm compatible with things in our list, you are going to be forced to write all these. Interfaces are an idea. They say, you must write all these methods. Inheritance says, here is the base class that has a bunch of stuff already written. You get all that by default. You can choose not to change most of it. But the chances are that since you're inheriting from it, you want to at least change some of it. Or at the very least, you're adding a couple of new things. Okay, so inheritance gives you actual implementation. Whereas implementing an interface says, I am choosing to adhere to an idea. That make sense? Let's go ahead and get that on a slide because this is important. Interface versus inheritance. Inheritance. All right, so interfaces are an idea. Classes that implement them agree to implement all of the methods that the interface dictates. inheritance is a starting point implementation that gives you ready to use code as a base with the opportunity / expectation that you will change some of it and potentially add more. That makes sense? The difference between those? So a good example of interfaces might be for, a driver for a operating system, Windows drivers, Linux drivers, Mac drivers, whatever it is. Every I/O device you have, let's say, will have a driver, whether it's a printer or whether it's a graphics card. Now, would you agree that printers and graphics cards do very different things? Yeah. So we don't measure our printer in terms of frames per second. Like, I just got this new Epson, so good. 190 frames per second sustained. Right? Yeah, we don't do that. But does that printer have to communicate with our operating system at some sort of level, just like our graphics card does? Yeah, they both have to talk to the operating system. They might talk about different things, right? They might solve different problems, but they're going to still have to adhere to the common driver interface that Windows provides, so that the Windows driver interface will talk to the graphics card and say, hey, who are you and what kind of device are you? What generic device are you? Graphics card will say, I'm a graphics adapter. So right off the bat, Windows will say, okay, I'll go ahead and load the default VGA adapter so that you at least function, right? So you grab any of you built a gaming machine, what happens when you put your $800 graphics card in, you got your 640 by 480 resolution, right? Because that's the default. That guy is built in terms of a standard plain Jane SVGA graphics card, right? And then once you install the driver for your expensive graphics card, that's when he tells the driver, the operating system, I'm a little bit more than that guy from 20 years ago. I got some horsepower over here, and here's how to use it. Make sense? Go ahead.
So the difference between an interface and inheritance is that inheritance expects you to change, doesn't expect you to use everything that it has, whereas an interface, like is more inflexible and has to, and expects you to.
I think that's fair. Yeah, it doesn't necessarily say you have to use it, but it says you have to build it. Yeah, you have that UPC reader at the grocery store. Chances are, depending on, how that store operates, they may only use 3 of the 12 functions of the UPC reader. But that reader has all 12 functions built into it because it's a requirement to be considered a UPC reader. Yeah, so an interface says, look, I don't care if you use the stuff, but you got to write it. Make sense? You can leave half of it empty. If it doesn't make sense for your implementation, no problem. But that's on you. So you write me that empty method. Otherwise, you can't claim to be following our standard. Make sense? Where inheritance says you are starting with a starting point, an actual true-to-life implementation that has stuff in it. And you either want to take all that stuff as is and then add to it, or maybe you want to take all that stuff as is and maybe change 1 or 2 of those things. So you decided to inherit because most of what you're doing is in terms of the default. And you just want to do something a little bit extra or a little bit different. That makes some sense? Yeah. Okay. So understand that interfaces and inheritance solve similar-ish problems, but they are different. And one is not better or worse than the other. They solve different problems. But there are important parts of object-oriented programming, not Java. Okay, we could have this exact same conversation if we're talking about Swift or C# or C++. It doesn't matter. This is an idea that is larger than a language itself. Okay. So in our implementation here, we have our employee adapter. We're going to go ahead and say, you know what? I'm going to be building an array list of employees. And we'll go ahead and implement an array list, or import java.util array list, so we have that. All right, so my constructor for my employee adapter, this guy right here, he takes in a context, a resource, and an array list. Now the very first thing I need to do is I need to build my parent. Actually, that's the wrong term. I'm not building my parent. I'm building myself in terms of my parent. So I'm going to call my parent's constructor that takes in a context, that takes in a resource, and that it takes in that list of objects. We add a slide here. Building an object in terms of its parent, i.e., call the parent's constructor from within the new object's constructor. If you do this, it must be the very first thing you do in the constructor. What does that effectively say? It says become identical to my parent first, then differentiate myself. Rather than differentiating yourself first and then possibly overwriting some of that by becoming your parent. Don't set your eyes to brown and then build yourself in terms of your parent where now your eyes get flipped back to blue. Start off with blue eyes and then turn your eyes to brown. Make sense? All right, so very first line, super is my parent, whoever that is. In this case, that is the instance of ArrayAdapter. And he has a constructor that takes in a context, an int, and a list. And I'm going to go ahead and call that version of the constructor. At this point, I am a plain Jane ArrayAdapter. I need to make myself more. Make sense?
Yeah.
All right. For Thursday, I'm going to give you some sections out of the book to go through that will be a setup for the 300 class. Those of you who are not currently enrolled in the 300 class, I strongly encourage you to enroll in the 300 class. It is possible, if you have a time conflict, to do the class online, where you watch the videos and do the homework and stuff like that. Although I would encourage you to know thyself. Decide if you are somebody that can stay on top of yourself and make sure you can watch the lectures and stuff like that. Some of you won't be able to do that, and you'll get to midterms and realize, oh, I haven't started the course. Okay? That won't fly. All right, so I encourage you to take advantage of the class. CSC250 is it. And I'll put the reading assignment up. We'll talk about the final exam on Thursday, and we'll finish this conversation about our custom ArrayAdapter. All right, questions, comments, concerns, bribes? Today, faculty, student, staff, Bible study, God and Garub. Go down to the cafeteria signing. Take your tray down to the terrace room. We'll save a seat for you. Oh, and Clancy, you're coming today, right?
Is this the last